Easily my most favorite lesson is implicit differentiation. Now, I really like this, but I also know that it can be pretty difficult for some people, so be patient with me, be patient with yourself. Um, it's called implicit differentiation because every equation we've had up to this point has not been implicit, so we have a new rule. Instead, every equation we've had up to this point is written explicitly, meaning that it's obvious. Y's are on one side, X's are on the other. Or if you've got, I don't know, P's and Q's, P's are on one side, Q's are on the other. So I have left out the quotient rule note just to show you what we're talking about. Let's see if I was smart and can actually view it. Yep. So here's an example. Y equals blah, blah, blah. Here's another example. F at x, which is y, equals blah, blah, blah. Same deal with everything. So if I change the letters, but still leave one letter, big yawn, one letter on one side of the equal sign by itself, that's considered explicit, which means you're doing explicit differentiation. But we're going to do implicit differentiation, which means that you're going to have equations where the x's and y's are all mixed up, meaning that the x's and y's could be on the same side of the equal sign. So here's an example, and I'm going to flip over to the next page. Here's an example. Here's an example. Now, the next page is the suggested questions. I do want you to know that this is a different kind of question than the first one and the second one. And it's because there's only one term that has in the x's and y's truly mixed up. I mean, this is all x's, this term's all y's, this is neither x's nor y's, this is where they're mixed up. But you've got to pay attention to places like that. Question 2, just x's, just y's, a number, combo. Combo number. So my recommendation every time you have a combo is that you bracket it off. So I am going to bracket this off in green. And in addition to bracketing off those terms, my recommendation is that you slice them, meaning you slice it between the x's and the y's. Because I hate to tell you this, but it's true. This is the product rule, and this is also the product rule. So you need to make a big deal about it, which is why I have the brackets. So let's start this. There's going to be a little trick. So be patient, be aware. So the product rule says take the derivative of the front, 2x. Multiply it by the plain old back, x cubed. Plus, for product rule, the derivative of the back, 3y squared. Here's the deal. Every time you take the derivative of a y, you have to slap down a special symbol to say, I am taking the derivative of the y. I recommend you don't use y prime. I recommend you make a big freaking deal about it by using dy by dx, because this is an xy question. And then, once you've done the derivative of the back completely, you times it by the front. And I tend to put all this still in a big bracket to make a big deal about it. Then I need a minus sign. And I've got another product rule coming. So big deal, derivative of the front multiplied by the back. Not the derivative of the y, just the y, plain old, so don't do anything crazy. Plus the derivative of the back. Ah, that's a y. Make a big deal about it. Multiplied by the front. Now, believe it or not, most people get all that right. And then they get to the other side and write down 10, when really you're supposed to be taking derivatives, and the derivative of a number is 0. So now our job is to make this a little bit cleaner. So this is 2xy cubed. This one, I can multiply all my letters together, because this is just one very spread out monomial. So 3x squared from here, y squared from here, with the dy by dx tacked on the back. That's my recommendation. I took it out of the brackets because I multiplied them all by the invisible 1 that's sitting here. So now this one, I have to take this negative and multiply it through. So negative y, and then negative 1x dy by dx still equals 0. Then I need you to take all the non-dy by dx's, so that one and that one, across the equal sign, because the object of this game is to find dy by dx by itself. So I'm going to do this in multiple steps, even though there are people who can do it in less than multiple steps, or less steps generally. So I'm leaving this behind. I'm leaving this behind. And then because I like to start all positive, I'm going to take this negative y and write it down first here as a positive y. And then I'm taking the 2xy cubed and putting it there, and I need to subtract it because it's add over here. So this is the part some people can do in their head that I don't recommend in the first time you try this. We have a dy by dx here and here, so we're going to common factor it out front so there's only a single. So there it's gone. If you can common factor out more, don't. Repeat. And then we're going to have to divide on both sides. So I'm just going to leave it like that because dy by dx will end up as y minus 2xy cubed, what was there already, divided by this bracket, which is preventing the dy by dx from being by itself. So divided by 3x squared y squared minus x. And there is the answer. So you got to be careful with the product rule. You also have to be careful with everything else, but the product rule is a bigger deal. So I'm going to show the next question, but take a bit of a breather for my hand cramp. So there we go. I'll be back momentarily. So back with the first question for a second, because I want to show you what the question asks. And the question asks you to find or determine dy by dx, which is a fancy way of saying find the derivative. So then the next question says determine the derivative. So it asks the same thing, only in different words and different symbols. So let's take the derivative. We don't have any redoing of this. The only thing I suggest is everywhere you see x's and y's truly combined, you bracket them off and make a slice so that you can think, oh, this is a very big deal with product rule. So I'm going to take the derivative of the front, which this term does not have any y's. It isn't a product rule. It's just simply take the derivative of x. And x is not a big deal, so we leave it. Plus, big deal for product rule. The derivative of the front, the x, is 1 multiplied by the back, not the derivative of the back, but the back, so no dy by dx necessary, plus for product rule, the derivative of y is 1, that needs the dy by dx, and it also needs you to remember that you have to multiply by the front, because it's the product rule. Done that, minus sign, derivative of y squared is 2y, but it's a y, so we need this again. And then the derivative of 4 is not 4, it's 0. So I'm going to make this look pretty before I start shifting stuff around. So 2x plus y plus 1x dy by dx minus 2y dy by dx equals 0. So I'm going to do this in one less step than the last question. This should kind of remind you of some logarithmic work that we did in advanced functions, more specifically the exponential equations where you had to log both sides and then get the x by itself. Now we're getting the dy by dx by itself. So that goes over, that goes over. So I'm going to leave this behind and this behind. But I know I'm going to need to common factor out a dy by dx, which is why I'm leaving them behind. So I'm left with x minus 2y. So that's a little shortcut. Equals, you know in the last question I said I wanted my positives first? Well, both of these are negative, so it doesn't really matter all that much. And then my last line will be to take what is originally there and divide it by the whole problem on this side, which is I need to get rid of x minus 2y. Now, don't go crossing out stuff. Like, don't cross out this 2 with this 2, or this x with this x, or this y with this y. Totally not allowed to do that crap. So don't. There are multiple answers for this. I'm going to leave it like that, and hopefully you will be able to tell what you can do for common factoring out of negatives and stuff like that. So this is my answer. One of my answers. All the other ones are mathematically the same. So last question, do you see a difference? One difference, the instructions. Don't say find the derivative, don't say dy by dx, say differentiate, which is exactly the same thing. Second difference, oh my gosh, this is a big one. I'm given a number. In fact, I'm given two numbers. One number is the x, and one number is the y. I was not given that in this question. I was not given that in this question. So in the end of the two previous questions, I could calculate a formula for the slope of the tangent of a very ugly curve. I could determine a formula for the slope of the tangent of a very ugly curve. This time, I'm going to actually find out the slope of the tangent at a certain point of a very ugly curve. So, step one, I would say, is exactly the same, meaning that I would rope off my little product rule and slice it. That 3 is with the x, not with the y. It is literally sliced there. So now I can take the derivative. So the derivative of x squared is 2x plus, very big deal for product rule. Derivative of 3x is 3, multiplied by the back, which is y, plus the derivative of the back is 1, but I just took the derivative of a y, so I need to make a big deal about it, and then I have to multiply it by the front. That's the product rule. Plus, the derivative of y squared is 2y. I just took the derivative of a y. Equals, derivative of negative 1 is 0. So I'm going to make this look a little bit pretty, so no changes here. So 1 times 3x is 3x, and then I'll tack the dy by dx onto the back. Plus 2y dy by dx equals 0. So here's where it changes. Yes, of course, I can take this term to the other side and make it negative. I can take this term to the other side and subtract it. I can common factor dy by dx out of these two terms and divide by a bracket. But why would I do that when I have numbers that I can plug in for x and y and do a little bit of bedmass, which might actually be a safer approach? So everywhere I see an x, not a dx, but an x, I get to put in a negative 1. So there. And everywhere I see a y, I get to put in a 1. So here's another x, negative 1. dy by dx stays dy by dx, because really that's what we're after. That's what differentiate means. Plus, there's another y. There's another 1, dy by dx. So that's negative 2 plus 3 minus 3 dy by dx plus 2 dy by dx equals 0. So I can collect like terms, as in these are just numbers. So negative 2 plus 3 is 1. And here's negative 3 of these things plus 2 of these same things is negative 1 of those exact same things. So this is just algebra, and this is just fancy, freaking you out. So now I'm going to take the 1 to the other side, so I can isolate dy by dx, divide by -1 on both sides, and I have a real live version, a very specific version of dy by dx, an actual slope of the tangent. -1 divided by -1 is 1. So the slope of the tangent, if I drew this curve and then found -1, 1, and then I laid a line on -1, 1 that went through only that point, so it grazed this curve at that point, the slope of that line would be 1. That's what we found. However, A, I don't want to graph this, and B, I don't even want to imagine this by doing limits. I don't want to sub in x plus h for all the x's and do limits. I mean, it's practically impossible because you've also got y's. So there has to be another method, and this is it. It's called implicit differentiation, where your x's and y's are mixed up on one side of the equal sign. Not necessarily mixed up in the same term, but very likely that that happens in conjunction with other things, like them lying by themselves or not at all. So this in the book is pretty poorly done, but pretty important when you hit university or college. So there is a sheet, likely on the Google Classroom. It's attached. The answers, I'll make sure, are also attached. The sheet, all the front side, and then do the last question on the back. I am not really sure what the questions look like in the back, but I'm sure I've said that for a reason. So unless you want to punish yourself, don't do any extra. So that is my big speech. Hey, that is another short one. We'll be back to do some more stuff.